So welcome everyone to the Dig Deeper webinar number 6. Today's webinar is on remote sensing and biophysical closure challenges. This is a really great series for us and we're really excited to be having another of our Dig Deeper webinars. We'll just give people just another minute or so to join, but it's been a great series so far. We've had some really fabulous speakers, and once again today we have two really fabulous presentations. In a minute, what I'm going to do is I'm going to hand over to Jason Kirby, who's going to be coordinating for today. But I'd just like to run through a few little house rules to begin with. The first is that we are going to be recording the webinar. In fact, we've already started the recording. So you should see a link showing that the transcription and recording has started. We would like you to keep your microphones muted. If you're having any kind of technical issues, please use the chat function, which is where we can respond to those. We have technical people on standby to address any technical challenges. Now, the other thing I'd just like to say is when we come to Q&A, question and answer, we have the specific Q&A functionality. So we prefer to use the Q&A function for that, not the chat function per se. So the Q&A function is a slightly different button you have on the interface there. Now I'm going to go ahead and introduce Jason, and he will then introduce the two speakers for today. So Jason Kirby is a principal research scientist in CSIRO Land and Water, and he is also, of course, our program for Lidar for CRC Time. He's been coordinating in the CSIRO Land and Water Legacy Initiative and supports sustainable industries through his work and extensive experience as a chemical risk assessment expert and environmental chemist with a focus on ecotoxicology. His research has impacted various government agencies, industry and communities through an embodiment of science and regulation and through to key issues of social license to operate. So look, I'm going to hand over to Jason and then he will introduce the speakers, and then at the end of the day, we'll just come back. Just before you go ahead, Jason, I did want to do an acknowledgement of country. So we'd like to acknowledge the traditional custodians across all the lands on which we live and work, and pay our respects to elders, both past and present. Over to you, Jason.
Thanks, Dom. And I'll just apologise right from the start. If I start a coughing fit, it's just because I'm just starting to get over COVID. So I apologise right from the start if my voice is not very strong today. But thanks for that introduction, Tom. So it's my pleasure really to introduce two great speakers for today's webinar, Renee and Ewan. They're both great scientists and people who have had a hell of a lot of experience in their fields, that are experts in their field, and really great leaders of the foundational projects and the outcomes from those projects in the CRC. The findings from those projects leading forward, which is what we're here today as well. So right from the start, I'll introduce Dr. Renee Bartolo, who is the team leader for the Drone Operations and Technology Solutions team at the Northern Territory Supervising Scientist Branch, the Department of Climate Change, Energy, Environment and Water. Renee has more than 17 years experience in the measurement of reference ecosystems and monitoring of mine site restoration trajectories using remote sensing. Renee's current role focuses on research for the assessment of ecosystem restoration at the Ranger uranium mine, which includes development of closure criteria. And like I said before, Renee's here to give the findings from a project, from our foundational project in CRC Time called Transforming Disparate Approaches to Remote Sensing and Monitoring to Industry Best Practice. So like I said, very excited to hear the findings from this project, and now I'll just pass on to Renee now to do the presentation. Thanks, Renee.
Thank you, Jason. Let's okay.
It never comes out as quick as you want it, Renee.
I know. Okay.
I think you just need yep.
Got
Yeah.
that? Awesome.
Thank you.
Thank you so much for having me come along and speak to people about this project. I think it's a highly relevant and topical foundation project. I've just introduced the project team. There's myself and Professor Peter Erskine and Dr. Lorna Hernandez-Santon from the University of Queensland Centre for Mind-Land Rehabilitation, and also Dr. Adam Cross from Curtin University. And you can see we have a range of partners in the projects that form the steering committee and group, and I think I saw Kirsty Beckett's online, so she's the end use sponsor for this project. And we did have a really great feedback from the steering committee, and in particular Santiago from Rio Tinto and Julian from eMapper. So the problem the foundation project was aimed to solve to come up with a roadmap for was the application of remote sensing and monitoring, that it lacks rigour and adoption in the wider industry. So this was brought to the fore really by the partners from industry, and then as we unpacked it more, the regulators were also expressing sort of issues with how rapid the technologies for remote sensing and monitoring are being, are evolving over time. And the issue there is that there needs to be a need for consistent approaches and to report outcomes while you're working with rapid technologies. And the government regulators were saying, well, they need the confidence that the outputs are accurate and will meet regulatory requirements. And so there is a real need and want from those in the mining industry, particularly areas like the Pilbara, where you've got very, very large mine sites, and remote sensing is the right tool to be able to, monitor those sites. And then government regulators not really sure how to take data and use it or make decisions with it, from even though the mining industry is really wanting to use that sort of technology. So that's the real crux of the matter that we were trying to look at. And so for the research process to unpack that some more and come up with a roadmap for the CRC time to pursue, to get some to help resolve some of this issue, was firstly we did look at the stakeholder needs in more detail. So the steering committee were fantastic in providing their views, and then we did an online survey and some follow-up interviews in more detail with people where they said they would provide more detail. So that went to a range of stakeholders. We tried to push that out as wide as we could. And then there was another component running alongside that, which was assessing the current state of remote sensing and monitoring through a literature review, and mainly in the scientific literature, and then producing a publication for peer-reviewed literature on what we found. And from that, we were able to then develop the research roadmap for the CRC, and we focused on project partner feedback really in that, and that's where people like Santiago and Julian really sort of helped hone what that should look like. And then we also used the results of the survey and the literature review to inform that. And so we've completed the project reporting phase of that. We're still just working on the peer review publication. So our top key findings, and I'll drop down into a little more detail around these, is the number one was identifying issues with current monitoring practices. So we were able to unpack some of those current issues with with what's being done now. And so when we look at remote sensing, we're not just looking at monitoring technologies, any remote technologies, and I'll show some video of some different forms of that. We're not just looking at, the typical satellite imagery or drones. We're also looking at remote technologies on the ground as well, and that will need to be followed up in more detail. What we also found was that the Australian mining industry is well and truly underrepresented in the scientific literature around using these technologies. But however, the literature does demonstrate that these technologies are useful to the mining industry in monitoring, particularly in the rehabilitation and restoration phases. And the other key finding is, and the project partners really helped clarify this, was what's required in Australia is a minimum set of standards for remote sensing and monitoring on mine land, so that there's a framework for regulators and to accept that sort of report, that output that comes from these technologies, and also to provide some flexibility for the mining industry in the technology rapidly evolving and how it can be adopted. So some of the identified issues with the current monitoring practices, there are logistic issues on how these are deployed, and then there's also things around like mine capability and uptake in the industry. So do the companies have people that are trained in-house, or bringing in people like the Mets that can provide that capability and uptake on an ongoing basis? And then the regulation and compliance and governance piece is, how do you use these outputs from these technologies to inform regulatory decisions, assess compliance, and do we have the people in the government agencies that are responsible for these functions that are able to understand the outputs from these technologies as well? And there's definitely was the need for consistency across the sectors. So that's where we started talking about the minimum set of standards there. So if we have a look at one of our other major findings, that the Australian mining industry is underrepresented in the literature, the literature does demonstrate that the technologies are useful to the mining industry. But it did show that there's very little published out from the Australian mining industry. We know that people are doing amazing things. A lot of it's bound up just in grey literature that, it's commercial in confidence, and it's people's IP as well, or companies' IP, and that's preventing it from being more widely adopted. Some of the key research areas to improve current monitoring practices that came out, and these were both linked out of the survey we did and follow-up interviews, plus what was found in the lit review, is that the highest importance to monitor, people ranked vegetation composition. So, what species make up, say, a restoration area, erosion of landforms, and tailings. The most legally important themes that people felt should be focused on are infrastructure, erosion of landform, and fauna. The socially important ones are air pollution, noise, and dust, and that's no surprise. So how can these be monitored better? What are most ecologically important, and this comes to the restoration phases, is fauna, little organic matter, and once again, vegetation composition. When looking at how things should be potentially monitored differently, it was fauna, vegetation structure composition, and slope stability. And there was once again that standardising monitoring protocols that use best practice across a range of areas. So I think it wasn't a surprise that some of these things came through, particularly, vegetation composition, because, you're traditionally putting people out on the ground in quite harsh conditions where a lot of the mine sites are, and anything that, and over large areas. So, you can't capture that at those scales. So it's about how you can do that more effectively, safely, and get better results. And it's the same with the fauna. We found that fauna was there's areas around like the camera trapping that could really sort of change things there as well. And so if we look at one of the third finding that was a key one, and where I think the focus of the roadmap is going to end up in terms of impact, is a minimum set of standards for remote sensing and monitoring on mine land. And what that will potentially look like is a framework for regulators, as well as enabling mine sites to have flexibility to choose what monitoring information they provide to meet those regulatory requirements. So if the technology changes, or there's advances in technology, which it's rapidly changing every 6 months or so, and the way that the analytics happens is also changing, that framework provides for those changes to happen, not years out, but within months. There was also this standards for image processing. So, you could process your image to the, nth degree, but what is actually just required to meet regulatory frameworks. And data governance and quality assurance was a big thing there that was discussed. And so kind of linked with that minimum set of standards is continuous improvement in remote sensing research, technological change, and in particular ecosystem trajectory monitoring, where, mine site closure may often rely on an ecosystem trajectory approach. So if we have a look at how industry can use these findings, there's the optimizing of the utility of the data and price, and how that relates to completion criteria or closure criteria and management actions, so the management drivers, and that can be used in that ecosystem trajectory framework as well. And then there's the research component with the sampling framework for on the ground, so verification of data. And how can that happen? Well, we could potentially use traditional owners to be involved, and that's happening in a lot of places now. In situ sensor integration, so sensors in the field, and making sure things are statistically robust. And the issue of how this happens over life of mine, and that also relates to ecological trajectories as well. So, in the initial phase of ecosystem establishment, you may be using tools that are more in situ, or things like drones at much higher resolution, through to when you're looking at intermediate states and sort of towards the final sign-off stage. You may be able to start using high resolution satellites or something. It depends what you're monitoring. And so there's that post-closure remote sensing. And we did explore more around traditional owner involvement. So there's often a perception that you'd be taking people out of that equation when you're using remote sensing and monitoring technologies, but that's definitely not the case. It enables people to focus their effort when they're having to do on-ground assessments to where it's really high value, and you can't use remote sensing or automated analytics approaches as well. So some of the implications that came from this, and I do apologise for this, sort of, it looks like a complex diagram, but it's not. We really focused on the research roadmap to have a research component and an applied research component, and then how that would translate to CRC impact. So those red components there are what came from the stakeholder surveys and the interviews. And the stuff in text is really what was refined with the stakeholder group, the steering committee group, our industry partners. I think the important things to take away from that is there is some fundamental key research that has to happen still, and that's around the vegetation monitoring and how you develop appropriate standards. And then there's exciting areas that are starting to evolve around how you can link remote monitoring technologies with things like eDNA or omics for remote sites. So, perhaps using being able to develop relationships between eDNA omics to what you might see from a drone image. So measuring function from a drone image, and that's linked. So that would also potentially provide cross-links across other CRC projects, that piece. In terms of the applied research, it would be, there's a big stakeholder engagement piece here, and looking at perhaps some exemplar, models of how stakeholders engage with, science and the industry, and developing standardised monitoring approaches to address some of the key items like landform and slope stability. There are links with some of these things to impact pieces as well, of course. So the main impact we think that some of this will translate to is establishing a stakeholder group to test and validate monitoring technologies and compare them at exemplar sites from around the country. And there are some great sites that this can happen, and to bring in all those different stakeholder groups to be able to do that. And then looking at once again, the minimum set of standards would be a really key impact piece there. And providing training. So some of the capability issues that both the regulators and the mining industry were raising could be addressed by having a really good training piece within the CRC around some of this stuff, and particularly for traditional owner involvement. So sort of to contextualise some of this, I just want to leave you with some of the work that we do at the supervising scientists that forms some of the structure of what we were thinking about in this project as well, because we certainly work with the University of Queensland team on this as well. So this is how quickly the technology is evolving. We are trying to set closure criteria using reference sites and actually trying to measure the number of trees of each species present to help inform setting restoration criteria. And probably 12 months ago, the sensors and the drones weren't there that would enable us to do this. And this is one of our reference sites, and this is using like a kit for this is probably worth about $15,000 with a 48 megapixel camera. And you can see as we zoom in on that, this is flown at 40 metres, you can start to see trees below canopy. We've never really had the ability to look at that. We can see every leaf on every tree, and our botanists can certainly identify species from this imagery without having to go into the field. We can look at resprouts as well, low on the ground. And then the real interesting piece here is being able to look at things like leaf litter and seeing, ant holes. And, if you're thinking about nutrient cycling, actually developing real sort of functional indices, particularly around things like nutrient cycling. So this was super exciting once we saw that, and we do have a project using artificial intelligence now to run through all this imagery and identify tree species. This one is, it's exciting and a little bit creepy. This is Boston Dynamics Spot robot dog, and we put a Lidar on it, that black thing on its head, and walked it through Ranger Uranium Mines trial landform, which is about, I think it's 12 years up, getting there. And you can see this, it's working out how to walk through that landform itself. We can program that to walk transects, and it's producing a 360-degree LiDAR scan as it's doing that. Useful for areas where, there's high temperatures, you don't necessarily want to put people out there, but also you can imagine a future where you have kennels all over a large site and you just send out the dogs to go do the monitoring, and you can put different payloads on these things and code them however you want. So yeah, that was a super cool use there. And this was a gamma, like we just jerry-rigged something up. So this is a gamma survey. Typically it would take 3 people 3 days to go and do this survey. This is the Pit 1 revegetation at Ranger Uranium Mine. And we would be able to send something like, once again, send out the dogs, or, you can do multiple sort of surveys then that way. Yeah, so that's just a snapshot on that. And other things like fish community monitoring, instead of, you know, the more traditional methods of, say, pop nets or other, you know, catching fish, using cameras, GoPro cameras, and putting them all through like a water body, and then being able to set up artificial intelligence models that can sample that community and identify fish species. So yeah, please go ahead if you're interested in that approach. Brovnet.org is that website there. And I would like to leave it there, and thank you for having me.
Thanks, Renee, for a brilliant presentation. So, like Tom said right at the start, if you have any questions for Renee, now would be the time, because I think Renee's going to disappear from for a while because she's got other things to do. But if you have any questions, now's the time to throw them in the Q&A section. If you know, this is anything about remote sensing, and it looks like remote dogs would be a perfect time to have a conversation, or to ask a question, I should say. So I suppose I'll start, Renee, since I'm meant to be the chair of this. So so the best practice, you know, how do we drive a national guidance or a national best practice approach to using sensors then? By the sound of it, there's still a fair bit of research to go behind that, but how do we start putting that kind of framework in place now to make sure that this kind of technology and approach can be adopted for, in our sense, of leading to better closure?
Yeah, that's a really good question. And I think the only way to approach that is having really good stakeholder engagement across all the sectors. So that's the place I see the part the CRC can really take, you know, take leadership in that area with all the partners that it does have. Because if we don't do it that way, it's not going to be accepted or readily adopted or be the best product that it can be. So I think there's a real opportunity here, using a good stakeholder engagement model to push that forward, and using exemplar sites and bringing the best of those exemplar sites into the process as well, coupled with a good training piece.
Excellent. And someone's got a hand up. I don't know if that means they've got a question or not, but Matt, I suppose if you've got a question, I suppose write it in the chat or write it in the Q&A section would be good. And so following from that, Renee, so across the different jurisdictions or across the different states, how is remote sensing looked on? I suppose it's looked on as the future, but what stages are we able to, what stages are we across the different governments in actually being able to start doing this kind of best practice approach to trying to get something a little bit more uniform and standardised across Australia?
Yeah, look, I think it's different state by state, and also the skill base within those government agencies. So once again, it's part of that. Let's bring people together. Let's train people. Let's build a framework. And also we see turnover in some of the state, and that turnover in the state agencies has been, I think, part of the issue. That's what the project team we've been discussing. But then we have pockets such as the supervising scientists that have 40 years of just working on this. And so taking some of the knowledge from some of the university sector that's been working on this for some time as well, CSIRO, supervising scientists, to help drive that with some of these state agencies as well.
And the question has come through from Philip. How repeatable is your data collection over the long term? And have you considered adopting military survey technologies?
Yeah, good question. So at the moment, with the drone technology, definitely it's repeatable, and we do that quite frequently. And the things like with the AI, the analytics, that enables that repeatability to happen a lot more easier, say, than it had before. Military technology, I'm assuming referring to longer range drones. Yeah, so we do have some longer range drones. We're definitely interested in getting some of those sort of larger drones as well, and they'd be perfect for some of the places like the Pilbara to run trials like using that sort of technology. And even with the high resolution satellite remote sensing, the analytics around that are more repeatable now as well. So I think that repetition and repeat monitoring capability or ability to do that's there. It's just making it applied and putting it in practice.
Yeah, and I suppose just a follow-on from you. So the uncertainty, I suppose, associated with each of these, that's what we're getting down to when we talk about best practices and that. So
yeah.
a lot of things around forecasting, prediction are the same thing. It's great to have these things, but we really want to know what the uncertainty is to be able to have that long-term planning and monitoring moving forward.
Yeah.
Yeah. I think there's one more. There's another question from Matt. I see the focus is on monitoring. There is much work going on with 3D cloud-based data from sensors as part of automation, carbon analysis, bushfire hazards assessment. Are you aware of this type of work?
Yeah, I'm assuming that's referring to Lidar and yeah, structural measurements. Yeah, so we do use a fair bit of Lidar, and there was you know, Julian certainly had raised about using some of the environmental benefit markets and that carbon. There's a lot to learn from those areas and how they actually apply this. So we do have like that mentioned in the way forward as well, is to look at the environmental markets and how they're actually using the technologies. But yeah, LiDAR's pretty standard in a lot of mine sites now.
And how advanced is the data analytics then as well, Renee? Because this relies a lot on the data analytics, and I love that you were talking about AI as well. So
yeah,
yeah, that to me is when you get into the real novel aspects of some of these research areas, and a lot of times, you know, a lot of our partners will kind of back away from that because it is still far down the track. So how far are we along with the data analytics as well?
So like, yeah, the AI field is just evolving so quickly. The main thing, if we're using, say, like something like custom vision, so trying to mimic what the eye sees, that work, what the hold up with that when you go to use it is the labeling piece. So you need someone who knows what they're looking at in the image, and they need to just label. And it requires a lot of labeling to set up an AI model, like we found that with our tree species. But once you have got that labeling piece done, it's pretty straightforward after that. The really cool piece that we're now pushing towards is the edge compute. So not having to take the data back to wherever, you know, an office, but processing it there and then, either on the drone or in the field. So, you know, we've got like the Stack Edge, the Microsoft Azure's Stack Edge Pro. We're about to do a big field test of that. And there are companies that are working in this space as well. So, yeah, there's a fair bit around that sort of AI area that people might not be aware is actually happening.
Thanks, Renee. And a question from another question: what was the accuracy of the data and usability of the Lidar imagery captured by the Robo dog?
Yeah, all right, I'd have to go back and take that one on notice, not off the top of my head, but I will say it was really interesting. So the Spot dog has a core pack that sits on the back, and it's a little computer, and that did shut down. That's why we like testing things at Ranger up in the tropics. It shut down at like, I think 36 degrees, but the Lidar was able to keep continuing by itself as well. So there's that testing of technology in really harsh conditions that has to happen as well.
Okay. And there's just two other comments. So such work gets us into future planning rather than just monitoring, which is true. And there's another one saying Dendra Systems have been promoting similar technologies and AI analysis down to species levels, such as weed species, etc. Oh, we might have lost Renee. Oh,
yes.
Yeah. So
I'm here.
Yeah, thank you. So there's probably have to move on in a second, Renee. I suppose the last question I'll have for me is that where's next for this project moving forward? What do you see the low-hanging fruit for the CRC time moving forward? And I suppose you've already answered that in your presentation, but I think it'd be nice for people to know where you might be going next.
Yeah, so I think it would be about the key thing that would have to happen straight up is the getting relevant stakeholders together and setting up that core group to engage and look at those exemplar sites. And then, there's some key bits of research that could be spun up at the same time. I think, with what else happens across the CRC, seeing where some of the research plans might come out, if we can find areas that have overlap, particularly around maybe something like omics, and mesh together with them, that's where I think we'll see step changes and, sort of rapid R&D development there.
Thanks, Renee. Thank you. And if you have any questions for Renee, her email address can be found on the CRC website. The project can be found on the CRC Time website as well as Project 3.2. And like I said, Renee, thank you very much for your time today.
Thank you. Thank you for having me.
Thanks, Renee. And I suppose now, Ewan, I suppose we'll move on to your presentation now. If you want to pop it up and go for it, you can just give a try while I'm giving the introduction. So Dr. Ewan Sellers is the Research Director for Hard Rock Mining within CSIRO Minerals Resources Business Unit and the Research Leader with the Mining 3 Collaborative Research Partnership. Ewan has greater than 30 years experience in mining industry, combining numerical analysis of experimental work, I'll leave it at that, with field measurements integrated into knowledge management solutions for mining and blasting problems. Ewan has multiple journal papers and industry reports covering areas of research such as numerous different types of modelling approaches for soil rock failure and fracturing, seismology, in situ stretch measurements, optimizations of blast in theory and practice, and mine to mill value chain optimization. So a perfect person to be talking about the project we're about to get into. Ewan is here today to present findings once again from another CRC Time foundational project examining comparative closure, assessing biophysical closure challenges of different mining methods. And like I said, it's great to have Ewan leading this project with his years of experience, but also being able to pull together the team that has given us these hopefully great findings from this foundational project. I'm chancing over the place now, Ewan. I'll pass it on to you.
Yeah, thanks, Jason. So hopefully you can see my slide. I think Renee's was a tough act to follow, so hopefully we can talk about our project and our team and the journey that we've been on. And I think it really has been more of a journey project than a destination project. So there's a lot of work to still be done. So I'd like to acknowledge my co-workers, Dr. Ibrahim Fatih Salmi and Rafael Picarelli, who bring the additional mining background, and Ibrahim's PhD was on closure and subsidence, so he's got a lot of experience there. Laura Kuhar brought leaching and mineralogy experience, and Mohammed Samadilova bringing petroleum industry experience, and Glenn and Brian always brought enthusiasm and encouragement for us. So we thank also the partners of this project and the sponsorship through Mining 3. So the question that we posed was, how does the mining method itself influence the biophysical closure outcomes? And we know that CRC Time is largely working on fixing a number of the problems of the past, and those problems have been arising from different mining methods, conventional mining methods that lead to open pits, and that create large voids in the landscape, and underground voids that can create subsidence and danger to people. And a lot of the work that is being done is to change the closure outcomes, clean up, and rehabilitate in a better way. So the question that we posed was, if we keep continuing with those same mining methods, will we get the same outcomes, and shouldn't we be looking at new mining methods that will give us better outcomes? And but Obviously, when we change something, things are not going to be necessarily always better. And so we wanted to have a look at whether people think that these mining methods are better or there are additional risks. So we came from a place of mining and mining productivity, and it was really good for us to understand the wider range of closure and post-mining use. We understood from a geotechnical point of view that there's a lot of influence on the surface, for example, from subsidence, these kind of circular sinkholes or large-scale collapse from longwall mining operations. So there must be something connected to the mining method itself that is driving this changes to the landscape and to the post-mining usage. So that led us to a research process where we wanted to understand, review all the different mining methods, see how their closure outcomes would differ. We wanted to also understand biophysical issues. For us, biophysical was actually something quite new. So part of this project was getting familiar with those concepts and the diversity of the issues that can arise. Then we went to explore and see how we could simplify the categories that we had and use a particular system for looking at the ratings. And then we were going to go to have some workshops with a lot of participants that were going to discuss all of these issues, but due to the COVID challenges, we changed that to surveying some external parties. And so that gave us prioritized risks for these different mining methods, and also highlighted some specific unknowns that we had and that need to be considered for the future. So when we go and look at mining methods, obviously people have been mining for thousands of years and they've managed to create hundreds of different methods. So we wanted a simple classification for this approach. And so we realized that there is surface and underground, and those were our main classifications. And often there are some transitions from surface to underground, as we see in this little diagram here on the left. But let's just consider these in their own particular categories. So when we consider surface mines, we consider open pits, this classical conical shaped hole that you will see in the landscape, and then also strip mining, which has a slightly different interaction with the landscape, where you are digging overburden from one side of the strip and putting it on the other side, so effectively the hole is moving across the landscape. Then in underground, we have caving, where the rock falls down into the excavated areas and creates a hole on the surface. Longwall mining, which is digging those thin seams and potentially large-scale subsidence behind that. Room and pillar mining, which has square pillars that are holding up the roof. And hopefully, if the engineers have designed them correctly, they would provide a very good, solid resistance to subsidence. But obviously, with time and in water, those pillars can degenerate and collapse. So, and then underground stopes, where in real hard rock mining in veins and more disseminated ore bodies, you make large excavations with drill and blast and excavate and take that material to surface for processing. So those were the classifications that we started with. And then part of the influence of why we've been looking at changing mining methods is to consider the changing landscape in mining as well. So we realized that deposits need to get will become smaller, more distributed, deeper. There's lower grades, so we need to consider that there needs to be change in mining methodologies. Sustainability means that people have a much better focus on utilization of water and energy and environmental issues like tailings. And then from the mining house perspective, there is a requirement now from funding with effectively strings attached to making sure that ESG considerations are taken into account. So through Mining 3, we've been looking at 3 different sets of mining operations, which we call in-place mining, because we hope to move the material as little as possible, which means that we are expending as little energy as possible. So the first one would be inline mining, where you have selective mining of ore bodies and local processing. So you might have a small digging machine excavating material and then processing it right behind that and putting the material back into an existing underground void. We see a lot of interest in situ mining, where there's a permeable zone of rock. You drill into that and pump fluids through that will recover the minerals. And then somewhere in between, where you might create underground silos by blasting, but leave that material there and leach it and process it in situ. So creating the permeability in rock that doesn't have that permeability. And so we call that in mine. So the 3 mining methods that we wanted to compare and contrast to the conventional methods. So when we look at change, we're starting to see why are we going in a different direction to what's been happening for many hundreds of years. And optimized systems are optimized for productivity and not necessarily for closure. So when we start looking at different optimizations, we start looking at going in a totally different direction, and that has a whole lot of unknowns and it has its own risks. And so we wanted to get some idea of how that manifests with changing the mining method. And the question really comes as, if you have new methods, is closure actually really easier? This is an in-situ mining method in Arizona. It looks like there's some disturbance to the landscape, but potentially less than might happen if there's a large open pit there. But the question is that really true, and do other people see it the same way? And those are the questions that we needed to answer. Another question we needed to answer was actually, what is biophysical? So as mining engineers looking at productivity, making sure that as much material goes through the plant as possible, I suppose we are culpable in creating more tailings. So the question actually is learning to understand these different issues that many of the other people in CRHC time might be well acquainted with, looking at the totality of these biophysical issues, and that includes the landscape and topography, the flora, fauna and animals, and also particularly the water on the surface and underground, and then long-term effects like contamination that are achieved from minerals leaching out of tailings or waste dumps on a longer scale. And so if we swap back to conventional mining, we wanted to see, are these biophysical issues considered when we're choosing a mining method? And so we went into the literature and had a look at a number of different ways of choosing a mining method, and these criteria are fairly typical, really around mining ore body geometry and excavation efficiency, safety, and a little bit potentially around surface preservation. So there's very limited consideration of these issues when you're starting to design the mine. So you can see, therefore, that at an early stage, you're locking in potential biophysical challenges in the typical mine design and mine approach that we have. So then we wanted to know, how do we compare these, and whether these novel mining methods have less impact. So the challenge is that if something is new, it doesn't have a history. That can be good because it means it's a clean slate and you can try something different. But also people don't trust something if it hasn't been tried and tested and proven. So that was a challenge. And so to start out here, I think we decided to start out with this expert survey. So we wanted a framework for that, and we used the rock engineering system, which was developed by Hudson in the 90s, where experts can contribute to be able to rank quantitative or semi-quantitatively, I suppose, the different priorities in a system. And so you get a matrix of priorities on the left and your different systems on the right, and then each of the experts ranks each of these in terms of a rating from no impact to a critical impact, and then all of these are summed and you can do some statistics on that. So we really appreciate all the time and energy that the survey participants put into going through this quite complicated system. And so let's just have a look at what we got out of this. So in this, we're looking at a range of these biophysical risks that we identified. And then we're looking from the left, we have the novel mining, 3 novel mining methods. In the center, we have the 2 open pits, surface mining methods, and then the last 4 are the underground methods. So just in general, we see that people see where red is higher influence or issue. So that tells us that people see open pit as being a much higher, having a much higher biophysical effect than the other methodologies, and they understood that there were challenges in the underground, specifically around water and surface subsidence. And then in the novel mining methods, we see quite a range, so from high to low. So people seeing that there are benefits, but some of these risks are going to change, and particularly around water quality. So we ranked all of these for the totality of all the different mining methods. We see that water pollution and surface effects are the big issues, tailings and water use, indigenous land use, socio-economic issues are some of the top 10 things that came out of this. And sure, there was a limited sample, so I think we can't take these as an exact ranking, but it gives us an idea of where people were thinking. And then also we ranked the open pit methods, the mining methods, as in terms of how people felt that their issues for closure would manifest, and we see that surface is highest, and then the underground and the novel methods are interlaced further down, with the inline selective mining being seen as the least impactful. Then an interesting part of this is actually understanding what we didn't know, what were our unknown unknowns, and what were those of the experts. And so we tried to do this very simply and not necessarily statistically correct, but it's really about getting an idea of what people were thinking. So when we had a look at the number of people who couldn't or didn't respond to particular questions here in this rock engineering system matrix, we see that people really understood the open pit issues very well. We see that in the underground, there's a lot of people that answered quite a lot about water and subsidence, but there are places where they were unsure. But generally on the novel mining methods, there's a significant amount of unsure or lack of surety there. So we could potentially say that there's a low knowledge of underground methods, and that may just be the sample that we chose of experts. It's potential lack of confidence in understanding the new methods that is coming through in this side here. So just to then summarize the implications, that we see that the experts are saying that water pollution, water and air, soil and air pollution are highly important in considering biophysical impacts, and then the water and subsidence following on from that. But as I've said before, those experts, these opinions would obviously differ if you had a different set of experts. So the question would then be, how do you start to quantify this, these impacts more carefully? And if you have methods that haven't been tried out, how do you test those methods and in a quantifiable way against existing methods? And so that then links to where we see that the future work is in this area. So we see that once you've chosen the mining method, that effectively leads to your defined closure outcomes. And those are chosen at a very early stage in pre-feasibility or feasibility studies. And so if those studies are not considering the final impacts, then all of those biophysical impacts will be baked in. Obviously, there's good practice and less good practice. So, you know, there will be a range of outcomes around those. But in terms of the methodologies that we have at the moment, they are fixed in terms of the impacts that they will have. So we feel that there's quite a lot more research needed in how we bring these biophysical impacts and this understanding of the whole route towards closure to the into the whole planning, and especially at pre-feasibility and feasibility stages where people are rushing to get their ore bodies into practice and delivered. So then the other part of this is looking at these novel mining methods, and we see there's still a lot of work to be done on those, and research into those to be able to pilot scale test, maybe virtually test them with computer modeling, and then to be able to communicate these issues to the stakeholders and the mining engineers of the future. We see that there's a lot of places where the industry can use them, obviously in getting new outcomes out of these new mining methods. We see a lot of less impact if we change the mining methods, and with change will come different jobs and different opportunities, and hopefully reduced liabilities for mining companies and regulators, and potentially a lot of more research to come. And I'll leave it at there. Thank you very much.
Thanks, Ewan. Perfect timing. So we've got about 1 or 2 minutes for a few questions. So if you have a question for Ewan, please throw it into the chat section probably now than the Q&A one, because the chat seems to be working better. So if you've got any questions, now's the time. You can lower your presentation too, Ewan, if you can do that as well, that'd be good. So I've always got a question, Ewan. I'll start it off if no one else jumps in quickly in a minute. So with these unknown novel methods, then how should regulators, or what do we need to then start doing for startups or companies now wanting to take on board these new novel methods and have a system in place around hard rock mining and pits and etc. So what needs to occur to help that transition into some of these new novel methods that are to allow this transition to occur?
Yeah, that's a very good question, and I think there's two places here. And the one is obviously the regulators need to be sure that they are making the right change, and then the mining companies need to be able to mine these ore bodies and have the right technologies. And so I think the two parts go together, and together that really is required around this pilot scale testing, checking out what these issues are, and this is where we were sort of looking towards the next phases would be to sort of go through a virtual life of mine planning of some of these different ore bodies, so that we can see that and get different perspectives and look at how they manifest in different ore bodies, and then at the same time, I suppose, once people get they could be tested in places where there's hybrid ore. We've already got mines that you can clean up abandoned mines and test them where we can see some benefit. But it is definitely a challenge to start to get this going, because there's no history and no experience, and in terms of JORC you need to be able to prove some experience before you're allowed to go ahead with these.
Thanks, Ewan. And I suppose there's no other questions or comments coming down through the chat section, so we probably should move on now because it's almost our time. So I'll just stop there and just say that so Ewan can once again be contacted on his email through the CRC website. There's the project up there, the foundational. I think the report you said was up there as well, Ewan. So the report's up there as well. So if you have any more questions, please contact Ewan, and then he'll be able to get back to you about any questions you have. I just want to once again thank Ewan and also Renee for some really interesting presentations around their foundational projects within CRC time. And what I'll do now is just pass you back to Tom to wrap us all up. Thank you. Just need to drop your presentation again, Ewan. I think it's popped up again. Or is that yours, Tom?
No, that's me. We just had a very similar slide. It was
that's all right. That's all right.
Just
I'm losing my mind. Thank you.
Look, thanks so much, Jason. Thanks to Ewan and to Renee. Also, another fabulous, awesome webinar with some excellent presentations. So look, that's sort of the end of the presentations today, but we did just want to say a couple of brief things. The first thing is that we will be having another webinar, which is currently scheduled for 21st of July. So please look out for information about that one coming through. We're also going to put in a little survey into the chat feature. So we appreciate any feedback you have about the whole webinar series and about the presentations today, which we'll put in the chat feature. But look, really the most important thing is to thank you. Thank you everyone who for participating. It really is an exciting event, which we're really pleased to be able to do. And I love reading all the reports, which I have a great joy of doing. But not everyone gets to read every report, and these webinars, they're really fabulous to convey the sort of the essence of the project in this format. So thanks everyone, and we look forward to hearing from you again on the 21st of July.